This is problem 4 of 8GA4, where we're talking about proving whether or not figures are similar. Given two similar two-dimensional figures, describing a sequence of transformations that can prove their similarity. Now let's remember, to prove two figures are similar, first you need to have a dilation by a scale factor, and then you can have a series of congruence transformations like rotations, reflections, and translations. The key is to map one onto the other, first dilating one of them. Here are two figures, DEF and XYZ, shown below are similar. Triangle XYZ was created by forming two transformations on triangle DEF. Describe a sequence of transformations that could have caused triangle DEF to result in triangle XYZ. What I need to do is give a sequence of transformations that would map DEF onto XYZ, and I have to start with a dilation. Okay, so let's start with the dilation, and we're starting with DEF. If I'm starting with DEF and I'm going to XYZ, I'm making this smaller. So I am going to dilate by a scale factor that is a fraction, a positive fraction, something between 0 and 1. Something like 1/2, 1/3, 1/4, 2/5, something like that. So let's see what our scale factor could actually be. Let's find two sides and two corresponding sides, and let's compare them. The side length on this one is 1, 2, 3, 4, 5, 6. This one's 6 units long. Its corresponding side is right here, and it's 1, 2, 3 units long. So if I go from 6 to 3, what do I have to multiply this 6 by? Wouldn't I multiply it by 1/2? 1/2 of 6 would give me 3. So my scale factor to go from this large triangle DEF to the small triangle XYZ is 1/2. Okay, so let's go ahead and write down that. That's our first thing that we're doing, our sequence of transformations. First thing we're going to do is we are going to dilate, and tell me what you're going to dilate. Dilate triangle DEF by scale factor 1/2. Okay, so let's do that with each one of these points and see where they belong. D is currently at 4, 2. I need to dilate it by 1/2. When I do, 1/2 of 4 is 2, 1/2 of 2 is 1. I'm going to have this point at 2, 1. Okay, let's do E. E is at 10, -6. 10, -6. Half of that would be, half of 10 is 5, half of -6 is -3. 5, -3, 1, 2, 3. Okay, so that's where our next point is. Now let's try F. F is at 4, -6. Okay, if I dilate that by a scale factor of 1/2, 1/2 of 4 is 2, 1/2 of -6 is -3, 2, -3, 2, 1, 2, 3. Okay, here's my triangle now. I can tell they're the same size, but I need to move this one up there to that one. What else do I need to do? Well, let's take this point and see where I need to move it. I need to move it up 1, 2, 3, 4, 5, 6, 7. So I'm going to go up 7. When I'm moving it, I'm translating it. Translate the figure, or translate the triangle. Up 7 units. Okay. Up 7 units puts it right there. Then we've got to go left how many units? 1, 2, 3, 4, 5, 6, 7. And left 7 units, right? Up 7 units and left 7 units. Okay, let's make sure it works for all the points. Up 7, 1, 2, 3, 4, 5, 6, 7, and then left 7, 1, 2, 3, 4, 5, 6, 7. And let's try this one. Up 7, 1, 2, 3, 4, 5, 6, 7, and left 7, 1, 2, 3, 4, 5, 6, 7. And notice, we have mapped we have dilated this figure, and then we have mapped it onto this one. If you can map them on top of each other using a dilation followed by a series of congruence transformations, rotations, reflections, translations, then you can prove that the two figures were indeed similar.